Good morning, students. In today's class, we are going to discuss about the implementation of logistic regression. So I'll just give a quick overview of how logistic regression works, and then we'll discuss the implementation part. As we know that logistic regression is used for binary classification. So if you want to divide your data into two different classes, so you can apply logistic regression. Okay. So logistic regression is a predictive analysis technique, we can say, which is based on the concept of probability, and the logistic function which we are using here is sigmoid function. So this is about the logistic regression. So now we'll give a quick overview that what data set we are going to use for the implementation here. So we are using here iris data set, which is a very popular data set in the field of machine learning and the statistic. And the use of this particular data set we can use for classification purpose, because this data set consisting of several features of the flowers. So this data set is consisting of a flower images, which is consisting of total 150 sample images of iris flowers, and it consists of four features, which is sepal length, sepal width, petal length, and petal width. So these are the features are available in this, and we're using these features, we are trying to predict that a particular flower is belongs to which particular species. So total we are having three type of species available in my data set, that is Setosa, versicolors, and virginica. So using these are the three classes which I want to classify. So my given image could be a Setosa, it could be versicolor, or it could be virginica, and I'm trying to predict using these four features. So this is all about my data set. So now we are going to discuss about the implementation of linear regression. So when we are talking about the linear regression, as we know that it is used for classification purpose. So first of all, what I have to do, I have to import all the necessary libraries for implementation purpose. So same thing we have done in the linear regression also. So we are just importing all the libraries. So I'm importing NumPys and Panda library. Okay, and I'm loading the iris data set from the sklearn, as I have to split my data into training and testing. So I have to I'm using here, I'm importing here from sklearn, I'm importing train test split. At the same time, I'm implementing logistic regression, so I have to import logistic regression from the sklearn. And if you want to check the performance of the model, you are importing some of the performance measures, which is accuracy, confusion matrix, and you are trying to visualize your data, so you can use either seaborn or matplot, any of the library. So this is all about the necessary libraries which we are importing. After importing the libraries, the next task will be the loading of the data set, which I told you earlier also. So we are loading the iris data. So I'm loading my iris data, and I'm keeping in a variable iris, and I'm defining a data frame which is consisting of all the features which are available in my data set. Okay, so I'm keeping in a variable df, and the target variable I'm keeping in a variable which is a with the name of target, and I want to just visualize how my data set looks. So my data set is consisting of four features. As I told you, it is consisting of sepal length, sepal width, petal length, and petal width. So these are the input features, and I have given for target values, or for the output, I'm using a variable name which is target, and this is my target variable. So 0 is representing that it belongs to first class. Okay, 1 will represent class 1, 2 class 2, and 2 will represent class 2. So in that way we are representing the target classes. Now I have to define what is my input feature and what is my target variable. So X is representing input features and Y is representing target. So I'm keeping target from the input features, and I'm keeping the target into Y. So I have to remove from the input features and I have to keep it separately. So I'm keeping in a Y variable. So this just we are defining target input features as well as in the target features. Now the next step is what? Next step will be splitting the data into training and testing, as we discussed earlier in the linear regression. I'm using X-train and Y-train for training data, and X-test and Y-test for test data, and I'm splitting my data into training and test. So I'm using X and Y variable here for splitting. 20% data I'm using for testing, and 80% data I'm using for training, and I'm keeping random state value equal to 42. So we have split the data into training and the testing. Now I have to initialize and train the logistic regression. So I'm using logistic regression. I'm calling a function which is my logistic regression. So I'm calling that, and I'm keeping maximum iteration value which is 200 here. So the maximum time, maximum, it will do the iteration of 200 times. You can keep any value here as per your requirement. So these are the sum of the function, these are the sum of the variables which we can change here, values which we can change here. So after this, I'm trying to fit my model for the training data for input features as well as for the label of the features. So I have built a model here, which is my logistic regression. So after building a model, now I want to check that how much my model have been trained. So I want to predict my results on the test data, as well as I want to evaluate the performance of my model. So I'm trying to predict the performance of the model. So what I have to do, I have to use the test data here. So I'm using the test data and I'm trying to predict my model. So I'm using model.predict. On what I'm doing the prediction, doing the prediction on the test data, which is only consisting of input features. I'm not taking any label of it, because during the testing we are just giving the input features, and model has to predict that it belongs to which class. But during the training we have to give input as well as the class label, okay, which we have discussed many times. Fine. So this is my prediction, and after prediction I'm keeping the result in y underscore predict. Now I want to evaluate the performance of the model. So as I told you earlier, we have different evaluation matrices in which we are having accuracy, precision, recall, and F1 score, and you can draw the confusion matrix, which is representing true positive, true negative, false positive, and false positive. And if you have all these four values, you can calculate precision, recall, F1 score, and accuracy also. So we are calculating here accuracy. To calculate the accuracy, we are using a function accuracy dot underscore, and I'm calculating accuracy between the actual value and the predicted value. And finally, I want to print the accuracy. The same way, I want to print the classification report, which is giving the result of actual value as well as in the predicted value. If you want to print the confusion matrix also with that, what you can do, you can you can use confusion matrix between the actual value as well as in the predicted value, and finally the confusion matrix will be given. So your classification report will give me precision, recall, F1 score, and support results, because as we have used a classification report between the actual value and the predicted value. And if you want to draw the confusion matrix, we have used this code for the confusion matrix. We have used this particular part of the code, and it is giving me this result on the confusion matrix. Now I want to do the visualization of my data. Okay, so whatever I have taken, these are in the form of numbers. Now I want to draw a graph for visualization, for better visualization. So I'm drawing the confusion matrix here. So to draw the confusion matrix, we have used the heat map from the Seaborn library, and we have here we mention the color, which is my color is nothing, color I'm using which is blue color, and I'm mentioning the target variable name also, and X label I'm giving the predicted, and Y label we are giving the actual. The title of the graph is confusion matrix, and finally I'm showing the results. So when I'll execute this particular line of code, I will get this confusion matrix. So this is my confusion matrix which I got here. Clear? So this is all about the logistic regression. So I hope it is clear to you that what exactly the logistic regression and how we can implement logistic regression. Thank you.